Hi guys, so in this video we will be solving this problem, swimming rising water. So first let's understand what the problem says. So in the problem we will be given a grid. Okay, so we have, it is a water, means we can travel in, swim in this grid, and we will be initially at the 0, 0 location, and our target will be this bottommost and rightmost cell. We have to reach this well by swimming across this pool or whatever grid you can say. Okay, if we, there are some constraints, like if we are at a cell, then we can swim to 4 adjacent blocks, right? But we should be inside this grid only, so we can swim to the 4 directionally adjacent cells. Okay, and the value in this cell represents something. What it represents is that, suppose if you want to travel to this cell, then it means that the height of water level in this cell is what, 13. So if you are at if your current level is less than or equal to 13, then you will have to wait for t equals to 13 second. And if your current water level is greater than 13, then you can simply skip through this cell, means you can swim through this cell in 0 time. Okay, this is what this means. So let me clarify this once again. What I meant by this is, what will happen is that initially what will happen, suppose if we are at 0 comma 0 cell. Okay, if we want to go to 0 comma 1 cell, then what we will see, that height of water level is 1, which is greater than our current level, that is 0. So we will have to wait for 1 unit of time. Okay, now if I want to go from 0 comma 1 to 0 comma 2, what I will see, the current water level is what, 2, and the maximum water level which I have traveled till now is what, 1. So again I will have to wait for t equals to 2 t equals to 2 seconds, or whatever is the unit of time. And this will go on, like we have to not sum up all the values, we have to minimize. The problem is that we have to minimize this time. We want to reach to this end bottommost cell, but the maximum time which we are taking in our path, maximum, not the sum, the maximum time which we will take in our path, we have to minimize that. Like suppose if I choose this path, for now if I choose this path, then the maximum time which I took in my path is which one, this 20 units of time. So I have to minimize this one. So if I take some other path like this, let's suppose if I took some path like this path, then something like this, then the maximum time which I took in my path is what, this is 16. So 16, and in this path it is 20. So I will consider this path because this is the maximum time which I stopped in my journey, in my path. Okay, so this is what the aim of the problem is. So now the problem would have been clear. So now let's see how we can solve this problem. Like the basic idea of problem is, this is what the basic idea of the problem. We have to minimize the maximum time which we stopped in our journey. And one more thing, like I have told earlier also, like if in my path I was initially at 0, at some in my path at some time I reached to, suppose I reached to height equals to 13. Okay, now again I move to cell with height, let's suppose 9. Then here I will not have to wait for any unit of time, because here the height of water level is what, 9, and in my path I have already come to height of water level what, 13. So I can simply cross this. Okay, so here I will have to wait for 0. Okay, so now let's move on to the solution part. Like the question would have been clear, I guess. So what we will do in this case, so what, we will have a destination point, like we have our source. Initially we are at what, initially we are at 0 comma 0, and we want to go to destination. Our destination is what, 4 comma 4. So what are the steps available to us? So we can go to any of the 4 directions, top, left, bottom, and down. So if I am 0 comma 0, then I can go to what, 0 comma 1, or and 1 comma 0, 1 comma 0, these two cells I can visit if I am at 0 comma 1. From 0 comma 1 again I can go to what, 0 comma 1 I can go to, 0 comma 1 I can go to 0 comma 2, or I can go to what, I can go to 1 comma 1, and so on. So if we look clearly, this is what, we are moving one by one. So we will be applying BFS only. This is BFF. We will be also applying BFS only for solving this problem, but not exactly BFS. What we will be doing is that in BFS what we use is queue. Okay, but here we will be using priority queue. Intentionally we are using priority queue. There is a purpose for priority queue. Like we want to minimize the maximum waiting time, right? We want to minimize the maximum waiting time, and queue does not help us in that. Whereas priority queue helps us. It helps us in finding a path which minimizes the, like suppose what will happen is that eventually we will start with this path. What will happen? We'll start with this point, and at a later point we encounter some very large value. So what we can do, we can revert back and check the other available options at that particular time. That can be done using priority queue only. But simple, if you use simple queue, then it will not help us in finding the minimum path. Let's take an example. Let me show you by an example how priority queue will help us and a simple queue will not help us in finding the minimum path. Let's take this. Let's consider a sub part of this problem. If we consider this matrix, this cell, okay. Let me give me a second. Okay, yeah. So if we have 0 1 24 23, okay, and 0 1 0 1, we are initially at 0 comma 0. We want to reach to 1 comma 1. If we use simple queue, then let's see what will happen. So what will happen, we will from 0 comma 0, 0 comma 0, what is the height of water is 0, so we will have to wait for 0 unit of time. We can go to what, we can go to 0 comma 1, sorry, 1 comma 0. This cell is 1 comma 0, 1 comma 0 with a height of 24. Since 24 is greater than 0, so we will have to, means if I want to visit from this cell to this cell, I will have to wait for 24 units of time. Similarly, from 0 comma 0 I can go to 0 comma 1, and my height is 0 and this height is 1, so it is higher than me, so I will have to wait for 1 unit of time. Okay, now we have completed this particular level. Okay, now we will move on to the next level. In the next level I will check 1 comma 0, and my destination is what, my destination point is 1 comma 1, sorry, 1 comma 1. So 1 comma 0 is not equals to 1 comma 1, so I will travel all the possible options from 1 comma 0. So from 1 comma 0 I can go back to 0 comma 0, but it is visited already, like we have already visited this cell, so no point of going there. So we will go to, from 1 comma 0 we can go to cell 1 comma 1. Okay, now here height of water is what, 23, and our height of water is what, 24. So initially we were at 0, now we are at a height of 24. Now I want to swim a cell which is at height less than me, so it will take me 0 time. Like, okay, so maximum time which I have waited in my journey is till what, 24 only, so I will show 24 here only. Okay, and from, so this part, no, from no other cells from 1 comma 0, I, what I told, why I stored 24 over here is that what we have to tell, the maximum time which we took in our journey, we have to minimize that. So maximum time I have taken in this path 0 comma, in this path is what, 24 only. That's why I am storing the maximum time as 24 only. Okay, now there are no more paths from 1 comma 0, so I will move on to the next cell, that is 0 comma 1. Is 0 comma 1 equals to destination? No, it is not. So I will travel all the paths from 0 comma 1 only also. So from 0 comma 1 I can go to what, I can go to 1 comma 1. And what is the cost will means time, 23. Here it will be 23 because initially I was at height 0, then I climbed to height 1, then I climbed to height 23. So 23 is greater than 1, so my time will be 23. So here it will be 23. Okay, now I have completed this level. I will move on to the next level. So I will visit this one. 1 comma 1 is 1 comma 1 destination. I have met the destination. And what is the time it is saying? It is saying that I took 24 is the time which I took to reach the destination. But if we look clearly, if we go by this particular path, then the maximum time which I will take in my journey is what, 23 only. But here it is on simple queue is giving us 24, because simple queue will not give us the shortest time. Okay, that's why we are not going to use a simple queue. We will be using BFS, modified BFS only, but we will be using priority queue, some Dijkstra type. This is, maybe you can call it as Dijkstra type algo. So we will be using priority queue because we are interested in finding the, means we want to minimize the shortest, minimize the maximum time we are waiting. So we are interested in shortest, so that's why we'll be using priority queue. Okay, so I guess this would have been clear, like why we are going with priority queue. So now let's see the algo in action, like how it will actually work. Okay, so we will be having a priority queue, so let's make a minimum priority queue over here. Let's make minimum priority queue. This is our priority queue. Priority queue. Okay, so initially our destination point is what? Our destination point is 4 comma 4, and initially we are at 0 comma 0. And what is the cost of 0 comma 0? Like height is what? 0 comma 0, height is 0 only, so we'll have to wait for 0 only. Okay, so one by one we'll remove elements from the queue. So we removed 0 comma 0 from the queue with height of 0, and we are checking, are we at destination? So we are not at destination. So what we will do, mark it as visited. Let's visit all the points where we can go. So if we go up, we will be out of the board, so we cannot go there. If we go left, then also we will be out of the board, so we cannot go there. So what we will do, we will move down. So if we move down, we will reach to 1 comma 0, and 1 comma 0 point is at height 24, and we are at height 0. So we will take 24 units of time to reach this particular point. Okay, from 0 comma 0 I can also go to 0 comma 1. So if I go to 0 comma 1, it is at height 1 and we are at height 0, so it will take us 1 unit of time. Okay, so I can go to these two locations. I will add this into my queue. So 0 comma 1 at height 1 and 1 comma 0 at height 24. Okay, now let's remove this element. Again remove, since it is a minimum priority queue on the basis of like maximum waiting time, minimum priority. So minimum is what? 1. So 0 comma 1 with weight of 1 will be out of the priority queue. Okay, now let's see, 0 comma 1, is it equal to 4 comma 4? No. So mark it as visited. Let's visit all the points where we can go. So from 0 comma 1, left is already visited, so we will not go in left direction. If we go up, we will be out of the board. We can go down. So if we go down, we will reach to 1 comma 1, and our maximum height till now is 1, and this point is at height 23, so we will have to wait for 23 units of time. And if I go right, I will reach to 0 comma 2. Our maximum height till now is 1, and this point is at height 2, so it is higher than us, so we'll have to wait for 2 units of time. Okay, we cannot go anywhere else, so let's add this into the queue. So 0 comma 2 with height 2, and 1 comma 1, 1 comma 1 with 23 units of time. Okay, now let's remove the next element. Next element is what? Which is the minimum among this? 0 comma 2 with 2. 0 comma 2 with 2. Okay, mark it as visited. Is it equal to destination? No. Mark it as visited. Let's go. Where we can go? We can go from 0 comma 2, we can go to 0 comma 3. We are at height 2, this is at height 3, so we'll have to wait for 3 units of time. And from 0 comma 2 we can go to 1 comma 2 also. 1 comma 2 also, we are at height 2 and this is at height 22, so we will have to wait for 22 units of time. So let's add it into the queue. 0 comma 3 with height 3 and 1 comma 2 with 22 units of time. Now let's remove the next element. Next minimum element will be 0 comma 3. 0 comma 3 on the basis of means height 3. So is it equal to destination? No. Mark it as visited. You can go to 0 comma 4. We are at height 3, it is at height 4, so we'll have to wait for 4 unit of time. And we can go to 1 comma 3 also. We are at height 3, it is at height 21, so we'll have to wait for 21 units of time. So 0 comma 4 with weight 4 and 1 comma 3 with weight 21 will be added into the queue. Now let's remove the next element. Next minimum is what? 0 comma 4 with weight 4. Is it equal to destination? No. Mark visited, where we can go from 0 comma 4. From 0 comma 4 we can go to only one spot, that is 1 comma 4, and it is, we are at height 4 and it is at height 5, so we will have to wait for 5 units of time. So let's add it into the queue. 1 comma 4 with weight 5. Now let's remove the next element. Next minimum element will be what? 1 comma 4 with weight 5. Since priority queue is on the basis of minimum weight, so always the minimum weight element will come first. So 1 comma 4 with weight 5. Yeah, this cell, is it equal to 4 comma 4? Not. So we'll mark it as visited and we'll visit it neighbors. So we can go to what? We can go to 1 comma 3 with weight 21. Since we are at height 5 and this is at height 21, so we'll have to wait for 21 units of time. And we can go to 2 comma 4 also. 2 comma 4, we are at height 5 and this cell is at height 16, so we will have to wait for 16 units of time. So we will add this into the queue. So 1 comma 3 with weight 21 and 2 comma 4 with weight 16 will be added. Now let's remove the next element from the queue. So next minimum is 2 comma 4 with weight 16. 2 comma 4 with weight 16. So is it equal to destination? No. market as visited. From 2 comma 4 we can go to 2 comma 3, 2 comma 3, and we can go to 3 comma 4. Now look clearly. From 2 comma 4, what we are seeing, 2 comma 4 is at height 15, and we have already traveled a height 16 in our path. So the maximum height we have traveled in our path, or the maximum time which we have taken in our path, will be what? Still 16 only. It will not We will not reduce it down to 15. Otherwise, again we will have to means count it. So we have the maximum we have traveled in our path is what? 16. So we will consider 16 only as the maximum in our path. Okay. And for 3 comma 4 it is at height 20, it is greater than 16, so maximum time it will take in our path is what? 20 only. So we'll update over here. Okay, now let's add these into the queue. So 2 comma 3 with 16 and 3 comma 4 with 20. Okay, now remove the next minimum element will be what? 2 comma 3 with 16, 2 comma 3 with height 16, 2 comma 3 with height 16. Is it equal to destination? 2 comma 3 and 4 comma 4 not equal, so it will be marked visited. This cell will be marked visited. From here we can go to, from 2 comma 3 we can go to where? 2 comma 3 we can go to 2 comma 2, 2 comma 2. Here also 16, since here it is 15, but the maximum we have traveled in our path is what? 16. So we will write 16 only as our maximum. From 2 comma 3 we can also go to 2 comma 3 we can also 2 comma 3 we can go to 3 comma 3, 3 comma 3 with what is the height? 3 comma 3 with 19, 16 and 19. This is at height 19, so we will store 19. And from 2 comma 2 we can also go to this point, that is 1 comma 3, 1 comma 3, and its height will be what? Its height is greater than our height, so 21 will be stored. So 1 comma 3 with 21, and 3 comma 3 with 19, and 2 comma 2 with 16. Now let's remove the minimum element from the queue, but before that let's erase these elements, empty the space. Okay, let's remove these elements. These are now no longer needed. So yeah, so now let's find the minimum element. What is the minimum element now? 2 comma 2 with 16, 2 comma 2 with 16. So 2 comma 2 with 16, is it equal to destination? 4 comma 4 no. So mark 2 comma 2 as visited. From 2 comma 2 we can go to 2 comma 1, 2 comma 1, and here it is at height 13. The maximum we have traveled in our path is what? 16. So we will store 16 only. That maximum we have waited in our path is what? 16 only. And from 2 comma 2 we can go to 2 comma 3, sorry, not 2 comma 3, 3 comma 2, 3 comma 2. It is at height 18, so 18 will be stored since 18 is greater than 16. So we will wait for 18 minutes of time. And from 2 comma 2 we can go to 2 comma not 3 comma where are we? 2 comma 2. Yeah, from 2 comma 2 we can also go to 2 comma 1 comma 1, 1 comma 1 with 23. So let's add these into the queue. So 2 comma 1 with 16, 3 comma 2 with 18, 1 comma 1 with 23. Okay, this will be added into the queue. Now remove the minimum element. 2 comma 1 with 16 will be removed. 2 comma 1 with 16 will be removed. Is it equal to destination? No. Mark it as visited. From here we can go to what? We can go to 2 comma 0 with 16, 2 comma 0 with 16, and it is 2 comma 1, right? 2 comma 0 with 16, and 1 comma 1 with 23, 1 comma 1 with 23, and we are at this cell currently, right? We are at this cell. From 1 comma 1 with 23, and if you go down we can go to 3 comma 1, 3 comma 1 with 17. So let's add it into the queue again. So 2 comma 0 with 16, 16, and 1 comma 1, 1 comma 1 with 23, and 3 comma 1 with 17. Okay, now again let's remove the minimum element. Minimum element is what? 2 comma 0 with 16. So 2 comma 0 with 16, is it equal to destination? No. We will mark it as visited, and we will add the neighbors. Its neighbors are what? 3 comma 0, 3 comma 0 with 16, and 1 comma 0, 1 comma 0 with 24. These are the neighbors. Okay, let's clean this. Okay, so 3 comma 0 with 16, and 1 comma 0 16, and 1 comma 0 with 24. Okay, now let's remove the minimum element again. So 3 comma 0 with 16, 3 comma 0 with 16, 3 comma 0 with 16. Is it equal to destination? No. Okay, so we'll add the neighbors. Its neighbors are what? its neighbors are 4 comma 0 with 16 and 3 comma 1 with 17. Since 4 comma 0 is at height, then it is lower than our height, and we have maximum we have traveled or waited in our path is what, 16. So we will store 16 only. Okay, so we'll add this into the queue. So 4 comma 0 with 16 and 3 comma 1 with 17 will be added into the queue. Now again, let's remove the minimum element. Minimum element is what, 4 comma 0 with 16. 4 comma 0 with 16. Is it equal to destination? No. Market as visited. From here we can go to 4 comma 1 with 16, and yeah, this is the only point from here we can go. So we'll add 4 comma 1 with 16, 4 comma 1 with 16. Okay, now again let's remove the minimum element. Minimum element is 4 comma 1 with 16. Okay, 4 comma 1 is not equal to 4 comma 4. Market has visited, add the neighbors. So 4 comma 2 with 16 and 3 comma 1 with 17 will be added. 4 comma 2 is at height lower than us, but in our path maximum we have waited is what, 16. So we will consider 16 only. And 3 comma 1 is at height greater than us, so we will have to wait for 17 units of time, which is greater than 16. So we have stored 17 over here. Okay, now let's add the elements. So 4 comma 2 with 16 and one more 3 comma 1 with 17. Now let's remove the minimum element, but before that let's remove the elements, some spaces. These spaces are not required to us. So the minimum element now is what, 4 comma 2 with 16. So 4 comma 2 with 16 will be removed. 4 comma 2 is it equal to destination? No. Market has visited, add the neighbors. So 4 comma 3 with 16 and 3 comma 2 with 18 will be added into the queue. 4 comma 3 with 16 and 3 comma 2 with 18 will be added into the queue. Again we will find the minimum element. Minimum element will be 4 comma 3, 4 comma 3 with 16. Is it equal to destination? No. Market has visited, add the neighbors. Its neighbors are what, 4 comma 4 with 16 and 3 comma 3 with 19. So 4 comma 4 is at a height lower than us, but in our path maximum we have waited, or maximum height we have reached, or maximum time we waited is 16 only, so we'll consider 16 only. So 4 comma 4 with 16 will be added into the queue, and 3 comma 3 will be with 19 will be added into the queue. Now again let's remove the minimum element. Minimum element is what, 4 comma 4 with 16. If we see 4 comma 4 is equal to destination, so we will stop over here. We have find the answer, and answer is what, 16 is the maximum time we have waited in our path. So our answer will be what, 16. So if there is a path, if we in this particular grid, in which if we travel that path, the maximum time we'll have to wait is 16, and that which is that path, this path. If we travel this path, if we see, waited for 0, we waited for 1, waited for 2, waited for 3, 4, 5, we waited for 16, now we waited for 15, but the maximum we have waited is what, 16 only. Means here we have not waited, since we have, once we have reached the height of 16, then we can directly go to height 15 in 0 seconds. So maximum we have waited till now is what, 16 only. From 16 to 14 we can go directly in 0 0 0 0 0 0 0 0 0 0 0. So maximum we have waited is what, 16 only. So and this is the path. Okay, so I guess the algorithm would have been clear till now what we are doing, but let's recapitulate it once again. So what we are doing, initially we are having a source, and we are having our finding our destination. And what we are doing, we are simply applying a BFS, but means modified BFS, not BFS, Dijkstra, something like that. But we are using a priority queue, and priority queue is what, priority queue of index. That is, what we are storing, I, which cell we are currently at, that is I comma j, and along with the maximum, means maximum weight, something like that, maximum whatever we have done, and we are having minimum priority queue on the basis of this maximum so far. So what we are doing, each time we are comparing our element with what, comparing with destination. If it is equal to destination, then what we do, we simply return the maximum so far answer. Otherwise what we do, we explore all four directions, all four possible directions, and again continue this process. This is what we do. So I guess the algorithm would have been clear. So now let's do one thing, let's try to code this problem. Okay, so now let's try to code this problem. So Let's discuss what we will do. We will start with, it is a BFS but modified little bit. We'll use priority queue over here. So let's use priority queue PQ equals to new priority queue. Okay. And we need something like this. We were storing in priority queue what indexes along with the weight maximum we have waited till now. For that we will have to make an object. So let's make a class, static class. Let's name it as pair. So we'll have a row, we'll have a column, and we will have a maximum so far value. Let's initialize it also, integer row, integer column, and integer maximum so far. This dot row equals to row, this dot column equals to column, and this dot maximum so far equals to maximum so far. Okay, and we'll have to like implement comparable of pair. Why do we need this? Like we want to minimum priority queue, right? So we'll have to implement a comparable for it. So let's implement that also. So public integer compare to, and it will have a pair class B. Okay, and we will return this dot maximum so far minus B dot maximum so far. Okay, so this will help us to our priority queue to short means element, to keep elements on the basis of minimum weight. So we want a priority queue of class pair. Okay, initially we will add what, priority queue dot add new pair of what, initially we are at 0,0 index, so 0,0, and the like what we were having source and destination. So source index is 0,0 and weight will be stored in matrix. So 0,0 and grade of 0,0 is the maximum height of water at that location. So we have added it. Now we will follow while priority queue dot size is greater than 0. What we are doing, each time we are one by one removing the element. So pair removed element equal to priority queue dot remove, and what we are doing, each time we were checking whether it was equal to destination. If it was equal to destination, then we were simply returning the maximum so far value. So if removed dot row is double equal to grid dot length length, and removed dot column is double equal to grid of 0 dot length, then we will simply return what, removed element dot maximum so far. Otherwise, if it is not, then what we are doing, we were marking it as visited and exploring all the 4 directions. So we first check if visited of remove dot row and remove dot column. If it is visited, then what we will do, it is already visited node, so we will skip this. So for that we need to make a visited array also. So let's make boolean 2-dimensional array visited equals to new boolean of grid dot length and grid of 0 dot dngtl. Okay, cool. New boolean of grid dot length and grid of 0 dot length. This will use for marking visited. If it is visited, then good. Otherwise, what we will do, we will mark it as visited of removed element dot row and removed element dot column equals to true. After that, what we'll do, we'll explore all the 4 directions. So for integer I equal to 0, I equals to 4 plus plus I, but for exploring we need a direction array. So let's make direction array, integer direction array dx, integer direction array dy. Okay, so if we are over here, we can go to 4 directions. And what are these directions? If we go up, it will be what, -1 0. If we go right, it will be 0 plus 1. If we go down, it will be +1 0, and if we go left, it will be 0 minus 1. So let's write it. So if we go up, it will be -1 0 or plus 1, that is 1 and 0. And in y, what will be the changes? 0, 1, 0, minus 0, minus 1. So these will be the changes in y direction. Okay, so now let's explore. New row will be what? Removed element dot row plus of dx of I. New column will be what? Removed element dot column plus of dy of I. Okay, now we will check if this is out of bound, something like this. If row is less than 0 or column is less than 0 or row is greater than or equal to grid dot length, length, or column is greater than or equals to grid of 0 dot length, LE. And one more condition, the point we want to visit, if it is already visited, then also there is no point of going there. So grid of row comma column, if it is already visited, then what we will do, we will simply continue. That is, we don't want this particular one, we will skip it. Okay, otherwise what we will do, if it is if it is passing all these conditions, then what we are doing, simply adding it into the priority queue. What we will do, priority queue dot add new pair of row comma column plus math dot maximum of removed element dot maximum so far, or grade of row comma column. Okay, this is for maximum, this is pair, and this is priority queue. Why I am using maximum over here? Like you can see what we were doing each time. If we are at a current height and we are going at a higher height, then our time will be maximum. But here, like you can see in these cases, when we are again going back from higher height, we are going to lower height. The maximum we have waited is what? 16 only. In our journey, we have to show the maximum time. So from 16, when we were moving to 15, 14 also, then the maximum time we have waited was what? Still 16 only. So we were storing 16 only in our diagram. Okay, so that's why we are taken the maximum over here. Okay, and finally let's write a return 0 over here. We'll get our answer from here only, but since it is integer returning, that's why we'll have to return a 0 to not to get any compilation issues. So I guess more or less we are done with our code. So this is the code for this particular problem. So till now, like, we have not updated the test cases in our portal. So by the time you will code this problem, you will get the test cases. So you can use this particular solution to pass the test cases and to check whether check the understanding also. So I hope you guys would have enjoyed the solution.